So let us see question number 2.10 from GATE 1992. It's a 1 mark question from XRD. Higher order reflections give dash error in the lattice parameter determined using X-rays. So basically he is asking us to find what happens to the lattice parameter finding error when you are using higher order reflections than your lower order reflections. Okay. So this is very important question. So let us see what could be the answer. So to know that particular concept, we will go back to our Bragg's law, which says that L lambda is equal to 2d sin theta, right? And we know d is equal to a by root of h square plus k square plus l square, right? Just substitute there. That means L lambda is equal to 2 into a by root of h square plus k square plus l square into sin of Bragg angle sin theta. So that means L being always constant, because we always consider first order diffraction, and lambda is fixed for the particular instrument, whether it's a copper target or cobalt target, right? That means if you want to find your lattice parameter A, it only depends on theta and h scale. Obviously h scale and theta are interrelated, because the first reflection will be at a lower angle than your higher order reflection, because higher order reflection will take higher angles. That means these two are closely related. That means to find lattice parameter, it all depends on the type of theta. So based on the type of theta, whether it's a higher angle theta or lower angle theta, your h scale will be fixed. So if you can see this particular graph of sin theta versus theta, okay. So let us say from 0 to 90, sin theta will be from 0 to 1. We know that sin 90 is a 1, right? And sin 30 is 0.5, right? So sin 30 somewhere here. So that means the error will be, okay. So obviously this particular X-ray mission will have some error in calculating the theta. Let us say the peak it is showing at 20, it may be from 19.5 or 20.5 or maybe 19 or 21, because always every mission contains some error and we cannot avoid that. That means you will always have some kind of error, right, for every theta. Let us consider you are measuring your peak at this particular lower angle, okay. So let us say this is the average value what it showed you to the in your final diffractogram, in your final output, but it can be your error, whether it is a positive error or negative error, right? So based on that, your sin theta will always be some error, right? So that error will be something like this. Let us say there is one more peak at, let us say, some 80. The machine will have same type of error, that means 0.5 error, let us say. Okay, but the sin theta error will be very less. So that means even though your machine has some kind of error in calculating the theta, the output sin theta error can be minimized if you are measuring at a higher angle. That's why if you are considering higher angle, the error in calculating lattice parameter will be reduced, right? So that means for this particular question, the answer is less. Okay, less error.